Okay, Algebra 2, we are here with the chapter 1 through 3 review. And we're doing part 2 right now. This is part 2. I don't know how many parts I'm going to split this up. I'm trying to keep them to about 10 minutes apiece, so let's just jump right in. What do we see? I see write in expanded form. Expanded form. Oh, so that means just take these powers, that stuff, and just kind of like multiply it out, like rewrite it with multiple terms, or not multiple terms, but multiple factors. What would that look like? Well, it looks like I would have negative 2, and then y cubed would just be y times y times y, 3 of them. And then w plus 2 squared means there's 2 of those, so I'm going to have w plus 2 times w plus 2. And that's it. That's all we're really looking at. So negative 2 times y times y times y times w plus 2 times w plus 2. And we're done. That was easy. That's it. That's all it is. All right, let's look at another one here. Number 8 says simplify the expression. Ooh, we got junky exponents. We got zeros and negatives. And how do we deal with that? Well, let's see. Negative exponents mean that we're looking at reciprocals. It's kind of like 4 to the negative 1 was really like 4 to the 1 over 4 squared. It meant that you had extras left over on the bottom here, because if I were to rewrite that, that'd be like 4 over 4, 4 times 4. And then these 4s would make a 1, and we'd be left with 1/4. So that's what's happening there. 4 to the negative 1 really means 1 over 4 to the first power. All right. And then this negative 2 to the 0. So anything to the 0 means you had the same amount on top and bottom. So negative 2 to the 0, we're talking that that's really like negative 2 times negative 2 over negative 2 times negative 2. And I could have 3 on top, 3 on bottom, 1 on top, 1 on bottom, 4 on, what doesn't matter. But it's got to be the same on top and bottom. What's that winds up doing is making a whole bunch of 1s where you just got 1 times 1 times 1 times 1, and it equals 1. So, and that's what's going on with 0 power. So anything raised to the 0 power is just 1. So there's that. There we go. So 1 over 4 to the first power times 1, which is really just 1 over 4. All right, simplify the expression, and we got exponents. Write the answer in scientific notation. Okay, so we got some stuff going on here, and it's kind of hard to see at first, but let's just try and work our way through it. There's a couple of things going on. First, I see that I have 5.06 cubed times 10 cubed over 10.2212 cubed times 10 to the 8th cubed. Why do we have all these things cubed? Because of this cubed right there. It's really making an exponent for each of these 4 terms, the 2 terms on top and the 2 terms on bottom. And why is that really a big deal? Well, this whole thing with multiplying this out, that's kind of messy. Oh my goodness, is that messy. But I want to focus on these 10s and then kind of work in these other ones for an approximation there. I'm going to show you kind of a tricky way to work your way through this. So first of all, let's see what we got going on. 10 cubed, that would give me 10 to the 9th, because I got 10 cubed 3 times. Now bottom, 10 to the 8th cubed is really 10 to the 24th. So we got this kind of thing happening, and it means that we're going to have 10 to the 24th on the bottom, 10 to the 9th on top. So if we were to simplify that even more, 9 of these from up top cancel 9 of these from the bottom, and you're left with 1 over 10 to the 15th. And how am I coming up with that number? Because the difference between 24 and 9 is 15. So we got 15 of those 10s left over on the bottom. So we got that, and I shouldn't even have this equal sign here. This is kind of bad math. But that's okay. Let's take a look at what else we got going on. So I got 1 over 10 to the 15th times this other mess, this other hot mess going on here. We got like a 5 cubed over 10 cubed. Well, let's approximate those. 5 cubed is really 125. And 10 cubed is 1,000. And 125 over 1,000 is really 0.125. Then we got this 10 to the 15th, which is really times 10 to the 15th. So I'm guessing that's about what we're going to come up with. It's pretty close there. Not exact, but it's pretty close. And what I'm looking for then is, how do I deal with this decimal? Well, if it's got to be in scientific notation, that means we got to move this decimal over once. But if it's moved over once, I got to compensate it in the 10th power there, because it's like I'm dividing, or what am I? I'm multiplying by 10 there, so I got to divide by 10 over here, because that's really times 1 over 1. So that would give me 1.25 times 10, and since I divided by that 1 over 1, it's going to be 10 to the 14th. All right, I'm getting really close in my writing here. Let's make some space. I would have 1.25 times 10 to the 14th. Now that's a lot of estimation going on there, but the general idea is we kind of separated it all out. Then we started grouping these 10s and seeing what happened with that. We came up with the 15. Then we have this 125 over 1,000, which was an estimation because I just did 5 over 10. I kind of rounded off, not looking at the other pieces. And then I, had to move the decimal one more time to compensate, and that's how I got the 14. So a lot of steps in that one. That's kind of more technical than it needs to be. It's more of a calculator style problem.